Hello there. I am Saichan Ritvik Chinni and welcome to this demonstration of the Pyro heat balance web application. This web application aims to provide an integrated interface, a software tool to compute cooler and kiln heat balance. This includes simulating the heat losses in a kiln as well. Using a Python script, the heat balance sheets are computed based on the dynamic pressure values and velocities along with the other necessary inputs like the temperature, static pressures, and the fan outlet pressures. And based on the flow values that are obtained, the required heat balance is established using the laws of thermodynamics. For ease of using the simulations and downloading the Excel files, this web application was developed. So as soon as you open the web application, this is how it will look like, and you will be directed towards the user notes section in the navigation part of the sidebar. So this user notes section will provide the user with the basic guidelines as to how to use this web application. The main takeaway from this section is how your input Excel should be looking like, and if you have any confusion, then you may click on this hyperlink to see how it should look like. So first you have to enter the dynamic pressure values of the preheater downcomer ducts, then that of the tertiary air ducts, then that of the cooler mid-air, then the cooler vent air, then the ESP stack, and then you have to enter the velocity values of the cooler fans, and then again the dynamic pressure values of the kiln blowers, calciner blowers, and the PA fans. So the next question would be where to upload your Excel file, and that would be available in the sidebar over here in the Excel uploads. Here you should be able to see two browse files buttons. The first one is for uploading the dynamic pressure values and the velocities. So in the data that I am considering for the sake of demonstration, there are two preheater downcomer ducts, two tertiary air ducts, one cooler mid-air and one cooler vent air, but I'm going to back calculate the cooler vent air flow. Then there are 11 cooler fans. There is one kiln blower, one calciner blower, and one primary air fan. So this is that Excel file. And for computing the kiln radiation, you have to upload the kiln surface temperature sheet as well. This data was provided by the National Council for Cement and Building Materials (NCCBM). So once you're done with this, then you can work with the main dashboard of the web application, which is this, the fan. You may be able to see the fan flows, the cooler fans, the cooler heat balance, and the blower fans and the kiln heat balance. This is where you have to provide the additional inputs required for the establishment of heat balance. So in the first section, you will be asked to enter the temperatures of the fan flows. That would include the preheater downcomer ducts, the tertiary air ducts, the cooler mid-air, the cooler vent air, and the ESP stack. And also you will be asked to enter the diameters, the static pressures, the pitot tube constants, the power, and the fan outlet pressures. And in case you want to back calculate the cooler vent air flow, then this uh, option will pop up, otherwise it will not. And this density calculations expander is to calculate the density of the preheater downcomer ducts. Now these values that are being displayed are taking into consideration these default values which you can change depending upon the infrastructure of your cement plant. Now coming to the cooler fan section, the first thing that you have to enter is the pitot tube constant, and then in this section, which is labeled as the anemometer or not, you will have to respond via 1 or 0. If you have taken the measurement of the cooler fan via an anemometer, then you have to enter 1, or otherwise you have to enter 0. Then you have to enter the diameters or the areas of the cooler fans. Since for the final calculation, in order to calculate the flow, we need the area. In case you want to enter the diameter, the area will be automatically calculated and stored by the program. One tip would be before you enter the values, just select for which fans you want to enter the diameter or the area, and then enter the specific values. So, for example, say if I want to enter the diameter for the first two fans, then I will change this to 0, and then the rest will remain as 1 only, and then I will enter the values. Then the static pressures of the cooler fans you can enter by clicking on this expander, and then the power and the fan outlet pressures as well. These two are required to calculate the efficiency of the cooler fans and the fan flows. And the same goes for the power and the fan outlet pressures under the fan flows section as well. But in this case, the power and the fan outlet pressures will be asked only for the ESP stack and the preheater downcomer ducts. On to the next section under the main dashboard is the cooler heat balance. Here you have to enter only three values: the clinker inlet and outlet temperature and the cooler radiation losses. Moving on to the next section, which is the blower slash PA fans. Here you can enter the areas and the temperatures of the calciner blowers, the kiln blowers and the primary air fans. The final section under the main dashboard is that of the kiln heat balance, and you have to give basic information that is required for the input, like the moistures and the temperatures of the kiln feed and the fuel. The heat output information is also required, for example the radiation values of the preheater downcomer duct, the cooler radiation values, the tertiary air duct radiation values, and the return dust quantities of the preheater downcomer ducts. In this section, the heat of reaction section, the option will be given to the user to enter the heat of reaction manually or to calculate it using the Zur-Strassen formula. If you want to calculate it using the formula, then type 0, otherwise type 1 for manual entry. It will change to this. You can enter it directly over here. And then coming to the kiln radiation part, you can enter the kiln diameters, the ambient velocity and the units, and then the emissivity and the interval. These units are for the kiln surface temperatures, the Excel file that you are going to upload over here. Now if you want to download the data and view how the data looks like, then you can click on the respective sections. For example, if you want to view the data of the cooler fans, then you can click on the cooler fans button in the sidebar under the navigation menu. If you want to view the cooler fans data in the form of a table in the web application itself, then click yes on in this radio button, and the cooler fans data will be displayed. And if you want to download it, then you can click on this hyperlink and it will be available to you. You can click on it and you can view it in your Excel. The output is something like this for the data that I have tested this web application for. Then clicking on the blower slash the PA fans section, you will be able to view the tables for the individual fans as well, the kiln blowers, calciner blowers and the PA fans, and the sheet with all the fans included as well. You have to click on the three fans data and this will be generated. This is the final output. So keep in mind that these values are being generated using the default values that are in the web application. Then you can view the cooler heat balance sheets as well. Then the kiln radiation calculations. It would look something like this. These are the scatter plots. And then the kiln heat balance finally. This is how it would look like. Now at any point if you feel that the main dashboard is cluttered, then you can unclutter it by clicking on the dashboard reset button, and it will just remove everything else and you can work with just the main columns for the inputs. Now that finishes my demonstration of this web application. I hope this is of value to you. Thank you.